Hello, my name is Selena Norteños. This is Lab 21 Capacitance, and for this lab, we only had one experiment, and this is for Physics 2 laboratory. So, as an intro to this lab report investigates how capacitors behave in parallel and series circuit configurations, with an emphasis on how they affect LED lighting, calculating the equivalent capacitance for each configuration, and comparing the capacitance of various circuit configurations were among the rules of the experiment. So here we have some of the materials that we used. Well, all of them. Just we're missing the stopwatch here, but that was in my computer, so I couldn't take a picture of that. But if you see it, we have the snap circuit kit over here, which included two AA batteries, one 470 microfarad capacitor, one LED light, one K resistor, one switch, one 4 snap conductor, two 3 snap conductors, three 2 snap conductors, one 1 snap conductor, a AA battery holder, and a stopwatch, which I mentioned was a part of my computer, so I couldn't take a picture of that. This is the first video, and this is the first arrangement for capacitance 1. So right now I have my circuits kit arranged like this. I'm going to turn this on for 2 seconds. 1, 2, turn it off, and then put the timer until it fades. That was a capacitance 1 arrangement. So right now I have my circuits. So this is capacitance 2. Now I have arranged my circuit so that this is capacitance 2. And now I have changed the 3 snap conductor that was over here with the 100 microfarad piece right here. So I'm going to do the same as I did the last time. I'm going to turn this on for 2 seconds and put the timer to see how long it takes for the LED light bulb to turn off. So I'm going to turn it on for 2 seconds. 1, 2, turn it off, put the timer on. Now I have a capacitance 3. This is my capacitance 3 setup for the circuit, and now I'm going to repeat the same 10 trials I have been doing for the last capacitance configurations. So we're going to turn it on, 1, 2, and then off, and turn the stopwatch off. This is my capacitance 4. Last but not least, this is my capacitance 4 arrangement for the circuit. I have included this 470 microfarad capacitor over here in this area, which was not there before. And that's the only thing I've changed from capacitance 3. So now we're going to do the same exact thing that we've been doing on the past capacitance, which is turn this on 2 seconds and turn it off, and then see how much the timer hits when the LED stops shining. So right now I'm going to turn it on, 1, 2, and then wait, and then stop the timer. So as you can see, it lasted a little bit longer than the other capacitance arrangements. Last but for our results and table for the 4 different types of circuit setups, the experiment showed how adding capacitors in parallel and series arrangements affected a LED's behavior in relation to the circuit's total capacitance. The LED stayed a little bit longer in part 1 for capacitance 1 because a second 100 microfarad capacitor was added in parallel, increasing the total capacitance to 200 microfarads. In part 2, the total capacitance was reduced to about 82.5 microfarads by adding a 470 microfarad capacitor in series with a 100 microfarad capacitor for capacitance 4. This also lengthened the LED illumination period, and even more than the parallel arrangement. The findings support that the theory that while capacitors in series will result in a decrease in total capacitance, capacitors in parallel will increase overall capacitance and prolong the time of LED illumination. The LED stayed lighted longer with a greater capacitance in both parallel and series configurations as the observed data match theoretical predictions. Thank you.